Hello friends, this video on lines and angles part 11 is brought to you by examfear.com. No more fear from exam. Let's understand one more small concept, that the lines parallel to the same lines. There are two lines, they are parallel to each other, and there is a third line which is parallel to this, then all the lines are parallel to each other. That is, if two lines are parallel to same line, so let's suppose this is line L, this is M, and this is N. Okay, and if I say that both are parallel to M, L is parallel to M and N is also parallel to M. So in that case, if both are parallel, then I can say that L is also parallel to N. Okay, so if both the lines L and N are parallel to a common line, then both these lines L and N are also parallel to each other. That is what it says. Okay, so you have to prove it. Let's prove it. So then suppose there are three lines. Okay, L, M and N. Let's draw a transversal. This angle will be angle 1, angle 2 and angle 3. So angle 1 will be equal to angle 2. Why? And given L is parallel to M and M is parallel to N, right? And we have to prove that L and N are parallel. So since L is parallel to M, so they are what? Corresponding angle. Now let's take angle 2 and angle 3. They will be same. Why? Because M is parallel to N, so they are also corresponding angles. Using these two equations, I can say that angle 1 is equal to angle 3. So if you notice angle 1 and angle 3, they are in the same transversal. So using the theorem, in fact using the axiom now here, this is for corresponding angles, we had the axiom. Using the axiom, we can say that since angle 1 and angle 3 are equal, right? So we can say that L is parallel to N using corresponding angle axiom converse. Correct, because they are the same transversal. The same transversal is creating these two angles 1 and 3 and their corresponding angles, and since they are equal, that means L is parallel to N. And since we have proved this now, this is a theorem. This is a theorem. Whatever I showed, this is the theorem. Let me write it here. This is a theorem. This is not axiom. This is a theorem now because I have proved it. Right? Lines which are parallel to same lines are parallel to each other. Okay, and this is true even for more than 3 lines. So with this, I think we're done with the concepts. We'll solve some questions. I hope you understand why we have axioms and we have theorems. So we had axioms in the case of corresponding angles, where we proved this using just by construction, but for alternate angles, interior angles, parallel lines, right, we have proved it using axioms, so they are theorems. Okay. Also, linear pair of angles we proved using construction, that was axiom, but vertical opposite angle concept we proved using axioms and other concepts, not by construction, so that was a theorem. Okay, so with this, let's start with some numericals. The question says that if PQ is parallel to RS and MRY is equal to 40 degree, find XMY. The picture is not given. Let me draw this. This picture will be given for you in the exam, so nothing to worry. There is a line PQ, there is a line RS. They are parallel, and there is a point M here somewhere, right? And this will join this point, this will join this point, and this is X and this is Y. Now it is given that MXQ is 135 degree. It is given. MYR is 40 degree. So please note this figure will be given to you in the exam. So don't worry about this. You have to find angle XMY. Okay. So XMY directly we can't find. So let's draw a dotted line here parallel. Let me call it line L. So line L is parallel to PQ and is also parallel to RS. Because PQ and RS is parallel, so if you draw another line that will be parallel to both. Now if you see, I can easily find this angle because these two are angles on the same side. I can easily find this angle. That is also easy because they are alternate angles. So let me call this angle 1 and this we call angle 2. Okay. So I can just say that if you see angle 1 plus 135 degree is equal to what? 180 degree. Okay. Co-interior angle. So angle 1 is what? 180 degree minus 135 degree. And that is nothing but 45 degree. Similarly, angle 2 will be equal to angle this one 40 degree. Right? Why? They are alternate angle. So what do you have to find? I have to find angle XMY, and that is nothing but angle 1 plus angle 2, and that is nothing but 45 degree plus 40 degree, and that is 85 degrees. So we have solved it, but please note I have solved in a rough way. So in the exam, please write a better English saying that, for example, angle 2 is equal to angle YML. Right? Let this be point. Let this point be Z. YMZ. Why they are alternate angles? So like that you can write. You can write in a better English. Okay, this is rough. I am solving it in a rough way. The question says that if a transversal intersect two lines, so there are two lines, and there is a transversal intersecting them, such that the bisectors of the pair of corresponding angles, let's take these two as a pair of corresponding angles, and their bisectors, and these bisectors are parallel. So L is parallel to M given, and let's mark these angles 1, 2, 3, 4. And since they are bisectors, angle 1 is equal to angle 2, angle 3 is equal to angle 4. These are all given items. Right? Given that the bisectors are parallel, L is parallel to M, and since they are bisector, angle 1 is equal to 2, angle 2, and angle 3 is equal to angle 4, that is given. So we have to prove. So we have to prove that these lines are parallel. So let me name these lines AB and CD. So we have to prove AB is parallel to CD. Correct? So to prove AB is parallel to CD, and what we have to prove? We have to prove that angle 1 plus 2 is equal to angle 3 plus 4. Right? If you can prove that these are equal, we can say that if you can prove that this angle 1 plus 2 and angle 3 plus 4 are equal, we can say that they are the corresponding angle, they are equal. So by using axioms, AB is parallel to CD. Okay. Now L is parallel to M. So since L is parallel to M, we can say that just think of this line extended in this direction. Since L is parallel to M, I can say that angle 1 is equal to angle 3, corresponding angle. Okay. Okay. Now if you see, we have to prove what? 1 plus 2 is equal to 2 plus 4. So 1 is equal to 3 is given. We have already proved. So 2 is equal to 4. If we can prove, that will be great for us. But if angle 1 is equal to angle 3, I can say that instead of angle 1, I can say that angle 2. Instead of angle 3, I can say that angle 4. Right? This is equation 1, this is equation 2, this is equation 3. So this is using 1, 2 and 3 equation. Using 1, 2 and 3 I can say that angle 2 is equal to angle 4. Now this is 3 and this statement is, let's suppose, 4th. So using 3 and 4 I can say that you merge both, right? So I can say that angle 1 plus angle 2 is equal to angle 3 plus angle 4. Since I have proved this, with this I can say that this is 5. So with this, since this is there, I can say that AB is parallel to C using corresponding angle XA. Corresponding angle converse XA. Pretty easy. See, understand what we did. So we knew that there are these lines 1, 2, 3, 4, these angles. We just marked it, and it is given that 1 is equal to 2, 3 is equal to 4, and L is parallel to M. Since L is parallel to M, we know that 1 is equal to 3 corresponding angles. Now using these information, I can say that since 1 is equal to 3 and it is given that 1 is equal to 2 and 3 is equal to 4, with that I can say that 2 is equal to 4. If you add these statements, you get 1 plus 2 is equal to 3 plus 4, and that is what we have to prove it from the back direction. So see, to solve these kind of questions, you approach from given data, right? Given data. So from given data is parallel to M, so I can make out that these angles are equal in this direction. Plus result required. So the result required was AB is parallel to CD. Since AB is parallel to CD, we have to prove that 1 plus 2 is equal to 4. Somewhere you come up with one value. For example, in this we came up with this figure, right? So this data from L is parallel to M, and this was from P is parallel to CD, and this is angle 1 is equal to angle 2, angle 3 is equal to angle 4. So from these data, we tried to prove this, and from the result we knew that backward, if you apply backward logic, you knew that you have to prove this. And this all comes by experience, right? More you practice, more experience you get. And then we proved this, that angle 1 plus 2 is equal to 3 plus 4. And with that, you could actually easily prove that AB is parallel to CD. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.